In this video clip, we will talk about factor theorem. Factor theorem is based on the remainder theorem. Remainder theorem. Remainder theorem says that if a polynomial p of x, let's say is this one, divided by another polynomial, then the remainder can be found without doing the division, just by plug in 5 into the original polynomial. Right here is p of 5 equals 5 cubed minus 2 times 5 squared minus 25 equals 125 minus 100 minus 25. Then we'll get the remainder. Accidentally, right here, remainder is 0 without doing the division. That's what the remainder theorem says. If the remainder is 0, then p of x can be written as x minus 5 times a polynomial, q of x plus 0. Previously this q of x was found, is this one. But actually, we do not really need this q of x. We can just claim that the p of 5 is 0, then x minus 5 will be the factor of p of x. So actually, remainder theorem can be part of the factor theorem. It basically tells us that p of 5 is 0, then p of x is x minus 5 times q of x. Okay? Now, in general, is that if p of c is 0, then x minus c will be the factor of p of x. Here, basically, it says is x minus 5 is a factor of p of x. What's the meaning for the factor? It's like 6 divided by 2 is 3. Remainder is 0. Then 6 can be written as 2 times 3. So 2 is a factor. So is 3. That's the very simple meaning. So if a number can be written as a product of two numbers, then one of these or two of these will be the factor of the original number. That's one part of the factor theorem. Okay, so if you want to see the general proof, is right here. If you have a p of c right here is 0, then you then have a p of x equals x minus c times q of x. You do not really need to write out how q of x looks like. Okay, you can just claim x minus c is a factor. All right, and here from this part to the third row, that's basically the proof of the remainder theorem again. You do not have to repeat. Okay, p of c is 0, then by remainder theorem, the remainder r is 0, then p of x will be written in this way. So you can claim x minus c is a factor, or p of x has a factor x minus c. That's one part of the factor theorem here. Okay. What's the meaning for the other part? The other part is that if p of x can be written as x minus c times another polynomial, let's say which one we like. We may borrow the previous one. Let's say you may say another polynomial is s of x. Then what's going to happen? This basically says x minus c is a factor. This basically says x minus c is a factor of p of x. That's basically it says. It's like here, 6 equals 2 times 3, then 2 is a factor of 6. So it's 3. So if p of x can be written in this way, what can you conclude? Then you can conclude p of c is 0. Why? Because, you plug in c here, c here, c here. What do you get? You get p of c is c minus c times s of x. That's 0 times s of x. That's 0. 0 times anything is 0. Okay. So that's the other part of the factor theorem. So factor theorem says two things. One thing is p of c is 0, then you will have x minus c is a factor of p of x. That's from remainder theorem. The other part is even easier. The other direction says that if p of x can be written in this way, or x minus c is a factor of p of x, that's another way to say x minus c times a polynomial will be p of x. Then immediately we can claim that p of c is 0. Okay, because again, you plug in, replace x by c, substitute c for x right here. Then you can claim what? P of c is 0. So factor theorem basically says two things, two directions. One direction is p of c is 0. You can claim x minus c will be the factor. Okay, that's one thing. Another thing is that if x minus c is a factor, x minus c can be the factor of p of x, then you will have a p of c is 0. That's even easier. You plug into here. Okay? You will get p of c is 0. Alright? That's basically what factor theorem says that. For this mathematical statement, is they use only if. If we understand, this if we understand, if p of c is 0, then we have this one. Only if means what? If p of c is not 0, then x of c will not be the factor of p of x. That's basically what we did for this part. Okay? Yeah. Please review this lecture. I will see you next time.